For this course on visualizing data using Seaborn, there are a few prerequisites. For one, you should be comfortable programming in Python 3 since all of the demos in this course will be coded in that language. You should also have some degree of fluency using Jupyter notebooks, as that is the IDE which we will use during the demos. And though it is not a requirement by any means, understanding this course will be far easier if you have some experience with some of the other Python libraries which Seaborn is integrated with. This includes pandas, NumPy, and also matplotlib. So what exactly is Seaborn? Well, you can think of it as a data visualization library which is built on top of matplotlib and integrates with a lot of other data science as well as statistical libraries. So while matplotlib is a visualization framework which provides a lot of fine-grained control over the plots one can create, and it is also part of the PyData stack, Seaborn is something which provides higher level abstractions over matplotlib and is tightly integrated with the PyData stack. Seaborn also integrates with other data structure libraries such as NumPy and Pandas. In addition, Seaborn also provides support for other statistical and data analysis libraries such as SciPy and stats models. So, how exactly can we compare and contrast both Matplotlib and Seaborn? Well, Matplotlib is part of the PyData stack, which is the open data science stack available in Python. On the other hand, Seaborn is built on top of Matplotlib and is tightly integrated with PyData. Matplotlib allows you to very finely control every detail of your plot, and it allows you to do a lot of complex things with it. On the other hand, Seaborn works with plots at a much higher level, which makes it very easy to use for a lot of data scientists. On the other hand, it does take away some degree of control from the user. So, Matplotlib, as we have discussed, provides a very low level API to control your plots, while the PyPlot library of Matplotlib works at a slightly higher level. Seaborn, on the other hand, works at an even higher level than PyPlot. So, if you'd like to define plots for production use, such as a production website, or if you'd like to make some important presentations to higher ups in your company, then it's certainly possible to use Matplotlib. However, the task becomes a little more complicated because of the need to use the low-level Matplotlib API. On the other hand, some degree of fine-grained control is possible in Seaborn without having to access the low-level APIs. Now, let us try to understand where Seaborn fits in with all the other data science libraries. So, Seaborn is a package which you can install using pip install, and it is very closely integrated with the PyData stack. In fact, Seaborn represents a number of high-level APIs which provide a layer of abstraction over some of the other libraries within the PyData stack. So what exactly is included within PyData? So the one package which Seaborn works directly with is Matplotlib. In fact, it is built right on top of Matplotlib. Matplotlib itself is integrated with some of the other libraries within the PyData stack. This includes the NumPy and Pandas packages, which individually can be installed using pip install, but these provide essential data structures such as arrays and data frames, which are used to represent data. Now, within Matplotlib itself, there are a number of different modules which serve their own purposes. For one, the low-level APIs for Matplotlib provides a lot of fine-grained control over your plots. PyPlot, on the other hand, works at a slightly higher level, as does the PyLab module, and both PyLab and PyPlot work on top of the Matplotlib API. And Seaborn sits on top of all of these. So with all this talk of high level and low level, it makes sense to clarify what exactly is meant by those terms. For example, at the low level, your instructions may be of the form draw this curve, and the curve will be part of a much bigger plot. But when you're working at the higher level, you simply provide the data and then give an instruction such as use this data to plot a histogram. So, low level operations work with specific elements of the plot, whereas with high level operations, you simply define the type of plot you want and then supply the data. In fact, this high-level and low-level hierarchy is defined within the matplotlib codebase itself. So let us examine the hierarchy of various elements within matplotlib. So right at the top sits the figure object, and a figure consists of a canvas and axes. Your axes could be the x and y axis, or maybe even a z axis or others. And within these axes, there will be ticks. These could be minor and major ticks. And there are, of course, several other elements. In matplotlib, each of these components are of type artist, and there is a hierarchy defined for the various artists. So right at the top here, the figure is in fact a container class, while the other artists are more granular elements. Since the figure, along with the canvas and axes, are the top level containers, the higher level APIs such as PyPlot and even Seaborn work at this level. On the other hand, if you'd like to control some of the more minor artists, then you would need to use the Matplotlib API.